Today we're going to be factoring by pulling out the greatest common factor. Yesterday we were working on locating the greatest common factor and figuring out what the greatest common factor would be for a polynomial. Today we're going to use that to factor it. So the first part here is going to have a lot of work shown, but I'd like you to see how this works and what's really going on. When we get to our paper, we're actually working the problems. You're going to be doing this mentally and not showing all these steps. But I'd like to show you these steps just to start out with so you have an idea of what's going on. So yesterday we were looking at a monomial. We were finding the prime factorization for each monomial. So here we have a binomial. So if I were to factor the first one, which is 4x squared, the prime factors for 4 are 2 times 2. And if we factor x squared, that'd be x times x. So right here you can see the prime factors for 4x squared. Now we're going to look at the prime factors for negative 3x or 3x. 3 is prime and x is prime, so basically you just have 3 and an x. I didn't really worry about the negative right now. It's just you could say negative 3. If you look at the way I organized them right here, I lined up everything that they share. So they do not share a 3. That's why they're not lined up there. They do not share a 2. They do not share 2. So if you look at it this way, you will notice that the only things that these two monomials share is an x. This is what we did yesterday. So we know that x is the greatest common factor because that's the only thing they share. So we're going to pull that out. The greatest common factor is going to go on the outside of our polynomial. Now to figure out what's left, we're going to pull that out and see what's left. So if you look up here at 4x squared, we used the x's, we pulled them out. So what is left? We have 2 times x left. That is 4x. And down here we had a 3. It was actually a negative 3 that was left. So negative 3. So basically what we're doing is we're finding the greatest common factor. We're finding what they share. We're pulling it out. And then we're asking ourselves what is left behind. So this is kind of a long way of showing you that, but it gives you a visualization of what's really going on when we do this. There's what they share. Here's what was left. So here's how we write it. Again, I'm going to write this out using the prime factorization just to show you again how it works. Now both of these are negative. Since both of these are negative, I'm actually going to pull out a negative 1. But 12, yesterday we learned to find the prime factorization for 12 with the ladder method. We can divide by 2, we can divide by 2, so our prime factors are 2 times 2 times 3. And then we have an x, so if I write out the prime factorization for negative 12x, I pull out the negative 1, 2 times 3 times x. If I do the same thing for the next term, negative 8x squared, again we have two negatives, both are negative, so I'm going to pull a negative 1 out on both of them. 8, if we find the prime factorization for it, and you divide by 2, you divide by 2, 2 times 2 times 2 times x. So the way I organized it here is, again, is I just lined everything up so that you could easily see what they share. They both share a negative. They both share 2's twice and x's. So if you look at what they share a negative 1 times 2 times 2 times x. This is everything they share right here. And now I'm going to multiply them together, and that would be a negative 4x. That's how we find the greatest common factor. Now, if you look at each monomial to see what is left, you will notice that with the first one, all that's left is a 3. So inside our parentheses for our first for our binomial, the first term in our binomial would just be 3. What's left for the second one is a 2 and an x, so that would be plus 2x. So that kind of shows you what's working here behind the scenes, what we're doing. We're finding what they have in common. That is the greatest common factor. We're pulling it out, and we're seeing what is left. Now, of course, instead of writing out all these steps like this, we're going to try to get to the point where we can do this mentally. So I'll show you a little shortcut version here with the mental aspect to it. This is a trinomial. We have 3 terms. We have the numbers 8, 4, and 2. And I know that the greatest common factor for that would be 2. So I'm going to write my greatest common factor right here, 2. If I look at my variables, I have x to the fourth, x to the third, x to the second. So I take the variables they share with the lowest exponent. So my greatest common factor is 2x squared. Now, mentally, what you're trying to do here, basically, to see what is left, you're dividing each term by that greatest common factor. This is the same thing we were doing. I'm just writing it differently to see what is left. So inside our parentheses, we're going to write what is left after we take a 2x squared out of each term. So 8x to the fourth divided by 2x squared. 8 divided by 4 is, or 8 divided by 2 is 4. X to the fourth divided by x squared is x squared. So that's your first term. For your second term, you have 4 divided by 2, which is 2. X cubed divided by x squared, which is just x. And you have a negative 2 divided by a positive 2. Since we only have one negative, we know this answer is negative 1. And it's actually the entire term divided by itself. And anything divided by itself is 1. And it's going to be negative because there was one negative. So that is one way you can show your work instead of going through this. Now, with my PowerPoint here, I went through, and again, I showed you the prime factorization for each one. You know, we can locate what they share. That becomes the greatest common factor that we pull out. And then we look for what's left, 4x squared for the first term, 2x for the second term, and a negative 1 for the third term. Okay, let's look at this when we have a cubic trinomial, and we look for the greatest common factor. I see a 10 and a 20 and a 5, and I know the greatest common factor for those numbers are 5. We have y cubed, y squared, and y. They all share a y, with the lowest exponent would just be y. So 5y they all share. To find what is in the trinomial, when we take that out, mentally, you're going to divide each term by 5y. If it helps, you can write it underneath like this if you need the visual. So we have 10y cubed divided by y squared, which would be 2y squared divided by y. I said y squared. We have 20y squared divided by 5y. So we have 4y. Then we have a term divided by itself, which is 1. 1 negative, so we know it's a negative 1. So you have factored that trinomial. Again, on my PowerPoint here, I show the other way where we list out all of the prime factors. We look for what they share. That becomes your greatest common factor of 5y. We look to see what is left. 2y squared is your first term. 4y is your second term. And a negative 1 is your third term. If you look at 2x cubed y cubed plus x squared, first I look at the 2 and the 8, and I know the greatest common factor is 2. When I look at the variables, I see that they both share an x, and that is all that they share, so that's my greatest common factor. So now to find out what's left over, I'm dividing each term by 2x. So when I divide 2 by 2, that gives me a 1. X cubed divided by x is x squared, and there's a y cubed left over. I have 2 positives, so I know my next is going to be positive. 8 divided by 2 is 4, and x divided by x is 1, so it goes away. So our answer is simply 2x times x squared y cubed plus 4. This one we have 10 and 12. The greatest common factor for 10 and 12 would be 2. We have a to the fifth and a to the second. They both share a's, so we're going to take the one with the smallest exponent. They both share b's, so we're going to take the one with the smallest exponent. So we have figured out that the greatest common factor for those two terms is 2a squared b squared. To finish factoring, we're going to divide each term by 2a squared b squared. If it helps, you can write this underneath so you'll have something visually to look at. We have 10 divided by 2, which is 5. A to the fifth divided by a squared, which is a cubed. B cubed divided by b squared, which is just b. We have 2 positives, so we know we're going to have a positive. 12 divided by 2 is 6. A squared divided by a squared becomes 1. B squared divided by b squared becomes 1. They cancel out, so you're left with this. Now, if you want to go back and check it, some people say, well, do I need to solve that? Well, if you solve it, if you do the distributive property, what you're doing is you're going straight back to this. You can actually use that to check it. So if I were to use the distributive property here, 2 times 5 is 10, a to the 5th b cubed, which is right here, 10a to the 5th b cubed, and then 2 times 6 is 12, and then a squared b squared. So if I use the distributive property, I can check it, and I'm going right back to where I started again. The greatest common factor for this would be 6, 12, and 3 is going to be 3. They all share a y, so my greatest common factor is 3y. So I'm dividing each term by 3y. If it helps, write it down here so you can see it. I know that 6 divided by 3 is 2, and y squared divided by y is just y. I'm dividing 2 positive, so I know we have a plus sign. 12 divided by 3 is 4. X, and then we have y squared divided by y, which is y. Then we have a term divided by itself, but one of them is negative, so we have minus 1. Now again, if I wanted to check this, I could use the distributive property and go back to the original problem. So if I multiply 3y times 2y, I know that is 6y squared. 3y times 4xy is 12xy squared. Check that one. And then 3y times a negative 1 is a negative 3y. So you can check it by using the distributive property and going back to where we started. Greatest common factor for this polynomial, we have a 20, a 4, and a 6. So I think the greatest common factor would simply be a 2. If we look at our variables, we have m's in all 3 terms. The one with the lowest exponent is a 1. We have n in 2 of the terms, but not in the 3rd term, so it is not part of our greatest common factor. So we just have 2m that we are dividing each term by. 20 divided by 2 is 10. M cubed divided by m is m squared. Then we have a positive. 2 positives make a positive. 4 divided by 2 is 2. M to the 5th divided by m is m to the 4th, and then we have our n squared. And then we are dividing with 1 negative, so that would be a negative 3. The m's become 1, they cancel out, and you're left with n. Again, you could check this if you wanted to by using the distributive property, and you should go back to your original answer. So if we multiply this term times the first term, that would be 20m cubed, which checks. Multiply this term by this term would be 4m to the 5th n squared, which checks. And if we multiply this term by this term, you would have negative 6mn, and it checks. So we did it correctly. Okay, so this was factoring by pulling out the greatest common factor. Good luck with your assignment today.